Imagine you build the fastest spacecraft humanity has ever created. Not the kind we have now, not the crawling, fragile machines we send to Mars and call it an achievement. Something unimaginable. Something that burns through space at 10% the speed of light. A machine that would make everything we have ever launched look like a child throwing a paper airplane into a hurricane. You point it at the nearest star, Alpha Centauri, 4.2 light-years away, the closest sun that is not ours, the one star in the entire cosmos that is, by cosmic standards, practically next door. And you wait. You wait 42 years before it arrives. And when it does, when your spacecraft finally reaches another star after nearly half a century of travel, you realize something that will hollow you out completely. You cannot stop. You have no way to slow down. You will fly through that star system at 10% the speed of light and out the other side and into the void beyond forever, and there is nothing you can do about it. The universe did not build itself for us to cross, and the distance between stars. On a clear night, the stars look close. That is the cruelest illusion the universe has ever constructed. They hang there, sharp and brilliant, scattered across the dark like something you could reach if you just had a long enough ladder. Ancient sailors used them for navigation. Ancient storytellers connected them into shapes. Every civilization that has ever existed on this planet looked up at those same points of light and felt something. Wonder, guidance, the sense that the cosmos was speaking directly to them. But something is wrong with that feeling, because those stars are not close. They are not even in the same category of distance as anything your brain was built to process. The moon is 384,000 kilometers away, far enough that only 12 humans have ever stood on it. Mars, at its closest, is 54 million kilometers, a journey of 7 months with our best current technology. The sun, the star that owns us, the one that controls every living thing on this planet, is 150 million kilometers away. Alpha Centauri is 40 trillion kilometers away. Not million, trillion. Your brain cannot process that number. No human brain can. We did not evolve in environments where distances like that were relevant to survival. The number exists in mathematics, but not in instinct, not in feeling, not in any part of the human nervous system that was built to understand the world. And Alpha Centauri is the... Here is what we currently have. The fastest human-made object ever launched is the Parker Solar Probe, a spacecraft we sent to study the Sun that, at its closest approach, reaches speeds of around 690,000 kilometers per hour. That number sounds extraordinary. It feels fast. It is fast, by every standard that has ever mattered in human history. At that speed, it would take approximately 6,500 years to reach Alpha Centauri. 6,500 years, more than the entire span of recorded human civilization, doubled. The Parker Solar Probe, our fastest machine, our greatest engineering achievement in the category of speed, would need to travel from ancient Egypt to today and then again to reach the star next door. But here's the problem. Even if we somehow achieved 10% the speed of light, a speed so far beyond our current capability it might as well be magic, the journey still takes 42 years. And 10% the speed of light requires energy so vast it staggers the imagination. To accelerate a spacecraft the size of a car to that speed, you would need to harness more energy than humanity currently produces in an entire year for a car-sized object, not a ship capable of sustaining human life for 40 decades. The numbers do not get better when you do the math. They get worse. Even if we solved the energy problem, even if some future civilization cracked the physics and built an engine that could push a human-carrying ship to meaningful fractions of the speed of light, the human body has its own response to that plan. It is not a polite response.
At high fractions of the speed of light, interstellar space, which appears empty, becomes lethal. The hydrogen atoms drifting between stars, normally so sparse they barely register, become a radiation storm at relativistic speeds. Each atom hits the ship's hull with the energy of a high-speed particle accelerator beam. The shielding required to protect a crew from this becomes so heavy it makes the energy problem worse. More mass requires more energy. More energy requires more fuel. More fuel requires more mass. Every solution creates a bigger version of the original problem. And then there is time. Not the relativistic time dilation that science fiction loves, though that is real and adds its own complications. Just ordinary human time. A journey of 40 years means a crew that leaves as young adults arrives as elderly people, if they arrive at all. The psychological literature on long-duration isolation is not encouraging. 6 months on the International Space Station produces measurable cognitive decline, muscle atrophy, bone density loss, and psychological stress in otherwise healthy, highly trained astronauts. 40 years is not.
But it gets worse. Because even if you solve the energy, solve the shielding, solve the biology, even if you launch a crew and they survive the journey and arrive at another star system after 4 decades of travel, they are completely, permanently, cosmically alone. A radio signal travels at the speed of light. From Alpha Centauri, a message takes 4.2 years to reach Earth. Your crew sends a transmission the moment they arrive. We made it. We are here. Earth receives that message 4.2 years later. Earth responds immediately. We hear you. What do you see? Your crew receives that response 4.2 years after that. 8 years pass for a single exchange of 2 sentences. There is no real-time communication across interstellar distances. There cannot be, not without violating the speed of light, which the universe appears entirely unwilling to allow. Your crew at another star is not just physically isolated, they are temporally isolated. Every decision they make, every crisis they face, every discovery that changes everything, they face alone, without the possibility of consultation, without the possibility of rescue, without the possibility of anything, except the knowledge that if they send a message, their grandchildren might receive the reply. This is not a technical problem we have not solved yet. This is the universe telling us something about what it will and will not. And here is the scale that makes all of this feel almost small by comparison. The Milky Way galaxy is 100,000 light-years across. Alpha Centauri, the star we have been talking about, the one that would take 6,500 years at our best current speed, is 4.2 light-years away. There are approximately 400 billion stars in this galaxy. Most of them are vastly farther than Alpha Centauri. The center of the galaxy is 26,000 light-years away. The far edge is 100,000 light-years. And the Milky Way is one galaxy among an estimated 2 trillion in the observable universe. If humanity somehow solved every problem, energy, biology, communication, engineering, and launched ships at 10% the speed of light to the nearest stars, and those colonies launched ships to their nearest stars, and so on in an expanding wave of human settlement across the galaxy, it would still take millions of years to cross our own galaxy. Not thousands, millions. The universe is not too big for us to cross quickly. It is too big for us to cross at all, in any time frame that resembles human civilization. And this is where things change into something darker than distance. The Fermi Paradox asks a simple question. If the universe is this vast and contains this many stars, and many of those stars have planets, and some of those planets presumably developed life, and some of that life presumably became intelligent, where is everybody? The silence is total. We have been listening for decades. We have scanned the sky in every frequency we can detect. We have found nothing. Not a whisper, not an accident, not even ambiguous noise that could be interpreted charitably.
Some scientists believe the answer to that silence is the distance itself, that intelligence arises, looks at the stars, calculates what we have just calculated, and stays home. Not because the will is absent, because the physics is absolute. The stars are separated by distances so vast that even civilizations millions of years more advanced than us may have concluded what we are slowly concluding now, that the galaxy does not connect, that each star system is an island, that the universe built intelligence in 100 billion places and then placed each of those places so far from every other that they will never know about each other, that we are not alone, but we must.
Here is what I think about when I think about the stars. We are the only species on this planet, possibly the only species in this corner of the galaxy, that looked up and understood what we were looking at. Not just points of light, not just navigational tools or religious symbols, actual suns, nuclear furnaces, other solar systems, other worlds. We understood that, and we immediately wanted to go. That impulse, that refusal to accept the boundary between here and there, is the most human thing that exists. It drove us across oceans on wooden boats. It drove us into the upper atmosphere in machines that had no right to fly. It drove us to the moon, to Mars in proxy, to the edge of the solar system on the backs of machines still talking to us after 40 years in the dark. But the stars are different. The stars are the first thing we have ever wanted that the universe may simply refuse to give us, not because we are not smart enough, not because we have not tried hard enough, but because the distance between stars is written into the laws of physics at a level that does not negotiate. We are here, they are there, and the space between is not empty, it is full of time. More time than civilizations last, more time than species survive, more time than the universe seems willing to lend to anything as brief and fragile as us. We will keep looking. We will keep calculating. We will keep building faster machines and imagining better physics and writing equations that try to find the loophole the universe forgot to close. Because the alternative, accepting that the stars are decoration, beautiful and permanent and forever out of reach, is the one thing the human species has never been able to do. And maybe that refusal, even in the face of distances like this, even in the silence that answers every signal we have ever sent, maybe that refusal is enough. Maybe it is the only answer that has ever mattered.